All right, everybody, thank you so much for joining us for day 2 of our workshop. We had a great day 1. I hope a lot of you, we heard some great feedback. We're going to take it to the next level here. We're going to talk about how to actually take those RAG systems, evaluate them, what the best practice tool is to do this, and what we're seeing out in the industry in terms of LangChain, its production tooling. We'll even get a sneak peek at the end of the closed beta that we have access to, and we'd encourage everybody to go ahead and sign up to get access to. So today, what we're really focused on, again, we're going to align our aims, is we're going to focus on evaluating the systems. So everybody says, like, how do you know if it's good? How do you know if it's right? How do you know if it's correct? It's like, well, I mean, you know, basically people want numbers, and then they want to do stuff to the system, and then they want to see numbers going uppy. That's what they want to see. And when you make numbers go uppy, boss is happy, and everybody's happy. But you guys, as the builders, you need to like actually figure out, like, is this really better for the customer? Is this really better for the user? That's not what we're going to teach you how to do today. That's a your data problem. That's a you problem. But we will teach you how to make numbers go uppy for people. And so the improving of the RAG systems is primarily done with retrieval, and that's the place to start. If you improve retrieval, you improve generation, and that's what we're going to kind of focus in on. And then we're going to show you how LangSmith works and what it's all about. So we're going to basically do more RAG today, and we're going to get kind of meta with it because actually RAG wasn't a thing when GPT was trained, and so you know what we can do is we can build a RAG system to teach these models, or Llama 2, for instance, about RAG. And that's exactly what we need to do. Sometimes we need to teach it new knowledge using RAG. So if you ask GPT-4 what is RAG, it has no idea. But we can build a RAG system to answer it. And then we're going to RAG assessment our way through this, do some advanced retrieval, and continue on. So first of all, we have to do the same things that we had to do last time. We're going to use open source Llama 2. We're going to use open source embedding models. We're also going to use open source Facebook AI similarity search. But the setup for the Llama 2 is the same, whether you go to bit.ly/aimrag or bit.ly/evalrag, which is today. You're going to kind of want to go ahead and do the pregame stuff if you haven't done that yet. And we're not going to spend time on how to do that because we showed that yesterday. So just a refresher, though, for everybody and sort of fitting this into the context. I'm glad you're raising your hand because I'm gonna ignore your question, and the reason is because
your link is not right.
Is it bit.ly?
All caps. All caps.
Evalrag. Oh man. Live. Going live. Boom. Evalrag. Fixed. Doesn't work. tinyurl.com/evalrag. Oh my goodness. Because of course we would do that. Boom. Okay, thanks everybody. Thanks for your not asking the question, but showing us. So what we're going to do is we're going to try to get through the hour, and then we're going to open it up for questions for like 20 minutes, okay? Because we didn't really do a very good question and answer period. And so we want to give you guys plenty of time if you want to dig in on something, you want to talk about a personal use case, and then we can continue the discussions afterwards as well. So we're going to kind of keep it light, keep it tight. If you have questions, please write them down, and we will address them. Okay, so let's just recall when we ask a question to a RAG system, we create a set of vectors or a single vector that is going to go ahead and go into our vector DB. We're going to look for similar things. Those similar things are going to be added to the prompt template we set up to say, hey, all these references that you're going to look at, use those to improve the generation, and don't answer the question if you don't know the answer. So everything that we take out and we find is similar, we put into the context. And once it's in the context window, if we did our retrieval well, it improves the generation, which is our answer. So retrieval done well equals generations that are better and more fact-checkable, and overall, just something that people will believe. Let's zoom in on the models here. And the models here, the embedding model and the chat model, we're using open source models today. We saw this last time. We're using the BAII BGE base, solid one. It's near the top of the massive text embeddings leaderboard. It's also small enough that you can run it on a relatively small GPU. The new research, Llama 2, still using these two, same as yesterday. All right? Welcome in, everyone. So what we're doing is we're taking these models and we're going to add a little bit to our stack here. What we're going to do is we're going to do what we're calling meta RAG. So we're actually going to search archive papers, and those archive papers are going to be on RAG. So we're going to do RAG on RAG papers. And we can actually do this really, really easily in LangChain. So the archive papers has a quick integration into LangChain. This is very easy to do. And we'll go ahead and we'll take those top 5 papers, usually 5, sometimes Chris changes this on me, and then convert those papers to embeddings, right? Tokenization, embedding, top K of them. We're going to put those into our vector store. We're going to use the face vector store this time. We're going to ask specific questions related to the content, like what is RAG, and we can return answers to questions with sources. Okay, so if we kind of start labeling things around our diagram, what we can see is we're actually going to start to be able to piece this together and get a little bit more meta even as we move forward. So we'll be able to ask questions like, what is RAG? We'll be able to get an answer that's true, not just like some random thing about a RAG. Like if you look for RAG memes right now, they're not good and they're not relevant. They're pretty dark sometimes, actually. But we're using a Hugging Face embeddings model. We're using Llama 2. We're using the Facebook AI similarity search as a vector store, and we're using the archive integration to LangChain. And so what you can see and what you can recall from yesterday's session is that we have this LangChain glue all over the place. And so the glue is really the infrastructure piece that's holding all of this together. And yes, we can do it in a naive way, and yes, we can do these things in naive ways, but why would we do that if LangChain's easier, faster, quicker to get up and running? And so this is the big idea of our meta RAG system, and we're going to go ahead and go straight into meta RAG, and you're going to see exactly how this works. So, Chris, you're up. Meta RAG, let's go.
Alrighty, so we're going to do RAG on RAG. This is kind of just a primer. So if you followed along yesterday, none of this will be new to you. But if this is your first session with us, then this should hopefully catch you up pretty quickly. The first thing that we're going to want to do, and I recommend getting started on this right away, is we want to actually load our open source model. So we are going to be using Llama 2 again. So we're going to also grab a ton of dependencies this time. We're going to need a lot of different things in order to get this going. All the data that you need in the presentation, should you not want to get all the CSVs yourself or use OpenAI, you can download all the data at tinyurl.com/evalragdata. It's on our GitHub repo and our data repository for the MLOps conference. So if you need the data, you don't want to run it yourself, you can just grab it from there. So you can see how this thing works. You will need an OpenAI key in order to perform the evaluations yourself. Without it, we won't be able to test our model's outputs against that larger language model, which is what the Ragus framework is going to do for us. We're going to start with 5 papers from arXiv about the retrieval augmented generation query. So you can find that using the arXiv loader from LangChain. Very useful tool. All we need to do is give it the query that we want, and it's going to load papers relevant to that query. We can check out that we have the survey on RAG, hybrid RAG, augmentation, adaptive retriever. We got a bunch of papers, and that's great. After that, we're going to do the same thing we did yesterday, but slightly abbreviated. We're going to create our embeddings model, and then we're going to chunk our papers, and then we're going to load our open source model. This is the same boilerplate we looked at yesterday, exactly the same copy and pasted from yesterday's presentation. So just load the model up, load the tokenizer, set specific stopping criteria, right? We don't want our model to ramble on too long. It will ramble on, but we want to limit how much it does that. And then we're going to create our Hugging Face Transformers pipeline, which we're going to wrap into our LangChain pipeline. And then we're going to set up our Retrieval QA chain. So we're going to set this up. This is like the basic, yeah, hey, what's going on? Oh, sorry, no questions till the end. That's right, no questions till the end. Yeah, you bet. We're going to create a Retrieval QA chain. And the idea here is that this is just like RAG in a box, right? We give it our LLM, we give it our retriever, and then we ask it to return source documents. This step is critical for using evaluation with these systems. Without returning the source documents, we are not going to be able to evaluate. We need to have something that we can use to guide us about, are we collecting the right things or are we not? So we have to return those source documents in order for this evaluation process to work. And then of course we have, querying. What is RAG? And we get, RAG stands for Retrieval Augmented Generation, is a technique used in natural language processing to improve the quality of generated text by retrieving and incorporating relevant information from a knowledge base or corpus, which is great because it used RAG to generate that answer, so love it. It also provides us an unhelpful answer, which we will see does not add to the viability of the model. So, this is the one of the things that we want to use perhaps better retrieval methods for or a different generator for, but we're going to talk about how you would evaluate this performance as we progress through. But that is it. That's all we have to do in order to get this RAG system up and running. Much shorter than yesterday, and that's why we wanted to start with how it starts, and then today we know, so we can skip all that. And there's your RAG.
All right, so that's meta RAG. Super quick, super easy, super simple now that we're all experts on LangChain and how to get RAG systems up and running. And you see, we can ask questions about RAG. Okay, great. Where are we going with this? Well, this is the point of today, is now that we have a RAG system, we need to actually evaluate it. And how do we do that? What's the best practice to do that? Well, these guys from Exploding Gradients created the best practice to do that. It's called the RAG Assessment Framework, or RAGAS, I'm not exactly sure, however you want to say it. Essentially what we're doing here is we're saying, okay, let me just squeeze down everything and let me understand exactly what's going on so I can start to make this a loop, so I can start to build this into a production system that is going to allow me to improve this over time. And we're basically just saying, is this going well? And we're putting a number on this. And then that's going to allow us to go, and it's going to allow us to say, okay, can we do this better? Does that improve our number? Can we change this? Does that improve our number? Can we really make sure that we're putting stuff in the right order, so that we're not producing a bunch of redundant things, or we're getting the most information in the right context here, and essentially getting finally a better number. So this is the big idea. So we're going to spend a little bit of time on this slide here. And this slide is showing the framework overall. We're going to walk through step by step exactly what's going on here. The most important thing to understand is that, we were talking about this morning actually with folks in a quick overview talk of what's going on in evaluation. Is the golden standard for evaluation is to not do any of this. It's to work with humans and be like, hey, is this thing actually really good for the problem that we're solving today? And it's to create that ground truth data set. Nobody wants to do this. Nobody's doing this. You're not going to do this. It's extremely expensive. It's extremely time consuming. The question is, how do we do something that is as good-ish, or at least is provably similar to doing a sort of ground truth, right? So if you believe that truth is real and reality exists, then the reference answer is sort of that truth. We have to generate this in order to assess in a loopable feedback way. This is the crux of the situation. So everything else falls onto the shoulders, the foundation of this reference answer, this ground truth. And so what we need to do is we need to say, okay, we're going to generate triples. We're going to generate query, answer, retrieved context, triples. This is the kind of thing that allows us to do fine-tuning later on embedding models, on LLMs. But importantly, this is sort of our Llama 2 generated answer. We still need a reference answer. And the thing is about the reference answer is you're going to need like the best, truest answer. And so like we basically are like, okay, well, let's just pick up the best model that produces the truest things. Now, the best model that produces the truest things again is a human that does this thing for a living. But as builders, you know, it's GPT-4. That's what it is today. Okay. So essentially what we do is we use the thing we built to generate our answer, and we use our RAG system to retrieve the context. And then we have to say, here's the truth. And this allows us to then go in and to look at, well, how well are we doing in terms of matching the retrieved context to the query? This idea of precision and recall, something we're all familiar with. And when we're looking at the sort of retrieval metrics of interest, we look at context precision and context recall. And when we go and we look at the generation metrics, these are metrics you're probably not going to aim at as much as the retrieval metrics, and we honestly wouldn't recommend it, but they've got great names, and in many of these frameworks, and people like them. They have names like correctness. They have names like, you know, faithfulness. You know, it's like, is it hallucinating? Is it not hallucinating? And so, you know, kind of what we're seeing here is we're seeing this way of putting a bunch of words together that make us feel good about how this is going that we can put numbers to. So one by one here, and just keeping in mind the fact that we're going to, in this case today, we're going to generate answers using GPT 3.5. We're going to generate reference answers using GPT 4 because GPT 4 is better than GPT 3.5. Otherwise, it kind of, even these frameworks, they don't really make a ton of sense. When we talk about faithfulness, what we're doing is we're comparing the generated answer to the retrieved context. Remember the first thing we ever talked about yesterday? It was, is your thing fact checkable, right? That you gave me an answer, but why? It's like, give me a reference, right? Is the answer related to the retrieved context? Very simple, right? So is it fact checkable? If so, high faithfulness. When we talk about this sort of answer relevancy, what we're doing is we're sort of computing this number that calculates sort of a similarity between the answer and the query. What we're kind of saying here, really, is we're saying based on the generated answer, would I expect to have had this query? So we're sort of backtracking. We're sort of saying, the answer that I got, what kind of queries might provide this answer? And how similar to that kind of thing am I? Again, the generation metrics are not the point, they're not the point of today, and they're not the place to start. Retrieval metrics are the place to start. And they're a little bit more straightforward, I would say. Because, you know, it's like the context relevancy. They changed the name recently. The context precision, formerly called the context relevancy just as a couple weeks ago, is really talking about whether the retrieved context and the answer are relevant to the query. So we're kind of, we're kind of splitting hairs when we do some of this. And there's different inputs and outputs. And I know a lot of people, what they want to do is as soon as they see this, they want to dive in. They want to see the vector math. They want to understand exactly how each of these things are calculated. And that's one of the things we've heard a lot of feedback on. But I think at a high level, it's important to understand that what's ultimately happening in the RAGIS framework is you're calculating context precision, you're calculating context recall, answer relevancy, faithfulness, and you're taking a harmonic mean of all four. And then you're saying, this is the RAGIS score. Now, it doesn't really matter what these numbers are. If you believe that they're telling you that retrieval is getting better or generation is getting better, then you set up your system to calculate these things. And as you tweak things, as you change things, as you set up a more sophisticated index, as you add metadata to your indexing scheme so that you're actually retrieving more relevant context, you should see some of these numbers, again, going uppy a little bit. And if you do, you feel good. It feels good to see that. But again, numbers go uppy depends on this. It depends on the truth. And, what is the truth? Well, it depends on the context, actually, in which you live and in which your company exists and your users and your products. Okay, so one more thing. This thing, what it does is it penalizes redundant information. So if you have a bunch of references, 100 references, 90 of them say the same thing, you're going to have low context precision. Okay? If we're talking about recall, we're saying based on this answer, would I expect to have retrieved this context? And these are the two things we're going to kind of focus in on as we look at exactly how we can calculate these things for our meta-RAG system. And this is what Chris is going to show right now.
Hype. Okay, so we have our RAG pipeline set up. We're very happy about it. It answers questions. Maybe it's good, maybe it's not good. But we want to kind of gauge, where are we at in terms of good versus not good. So we're going to go through a couple steps that are going to help us to determine, how it's performing. And the first thing we need to do is create a ground truth data set. Now, we're going to be using OpenAI to do this. Again, as Greg said, it's the best models that we have available. And because it's the best models, we can assume that it's going to be better at evaluating our model than, say, our model would be, or perhaps even other models would be. The first thing we need to do is we need to create questions, right? So we don't have questions about our data yet. We could do this manually. We could ask our domain experts at our organization to generate these questions. We could also ask them to answer the questions. So every time that you see this synthetic creation process, just remember that you can instead replace it with human experts to generate both questions and responses. But we don't have human experts that we're going to leverage today, and we need to do it quickly. So we'll use the LLM as a stand-in for that. The first thing we're going to look at is this output parsing for LangChain. So this is a useful pattern outside of this context, right? This is the way that we can actually conform our outputs from our LLM into a specific type or into a specific format. Very useful all around, but extra useful today since we want to extract a question from our response from the LLM. So we set this up, we create our schema, and then we use this parser in order to take the raw string answer from the LLM and convert it into an object of our desired type. So we want an object with that question key that contains a question. We have to create a prompt in order to generate these questions, of course. So we're going to ask the LLM to ask as a university professor who's creating a test for advanced students. We're going to feed pieces of context to this prompt. So what's going to happen is, we've chunked all of our documents into these bite-sized pieces. We're going to ask a question about that chunk. And we want the question that's generated to be about something in that chunk, right? The idea is we want to create a question that can be answered by that chunk. And this is the way that we can create a data set that can be leveraged for the Ragus framework. So it's important to note that we are asking questions about each chunk. Now, there are lots of chunks, so we're actually just going to use a subset of chunks here. We don't want to use every single chunk. That's a little too intense. We can see an example of this, though. What is the main focus of the paper? A survey on retrieval augmented text generation, and our context is the kind of header and part of the abstract for that paper. So the idea is we should be able to answer this question well based on the context that we've selected. We're just going to do a subset, so just 5 questions here, so that if you are running this through OpenAI, you don't have to break your bank, and you can see how the code is implemented. This is just as naive as you get. We loop through contexts, we ask the LLM to generate questions, and then we store them in a list. There you go. After that, though, we're going to need answers to those questions that we're going to assume are the ground truth, right? This is we're saying this is the real answer to this question based on that piece of context. Again, if you synthetically created those questions with context pairs, you could have a domain expert step in at this point and answer the questions based on those contexts and use that instead of the LLM approach. So if you're working in a space where you have access to those experts, that's a great thing to do. You've cut part of their workload down. All they have to do is look at questions, context, and give you answers. But again, we're strapped for time. We've got a little bit of cash sitting around, so we're going to get the LLM to do it. It's the same thing as before, where we're going to take advantage of the response schema pattern in LangChain to create an output parser that will give us just the answer. We don't want extra bits confusing the evaluation. We just want the answer to our question, so we're going to use the output parser to do that. And we use the same kind of prompt, right? You're a university professor creating a test for advanced students. For each question and context, create an answer. And then we want this JSON object with the correct keys. And so we get it out, and you can see the answer here, right? The main focus of the paper, a survey on retrieval augmented text generation, is to conduct a survey about retrieval augmented text generation, highlights the generic paradigm of, and it goes on and on. The idea is that we would consider this to be a high quality answer that we can test our LLM against. All we have to do now is convert this into the appropriate format. For the Ragus evaluation framework, it expects it to be in a Hugging Face data set. So we just, we have a list of dicts, so we can whip that up, no probs. And then, we go through everyone's favorite intermediary, pandas, and then we get our ground truth, question, answer, context data set. And that's the big idea of creating that data set. Once we have the data set, we're very happy. We can see we have our question, our context, our ground truth, some metadata. We have 5 rows of this. Now we can start thinking about using the Ragus framework, right? So it's fairly straightforward. In order to use this, it's outlined in their GitHub. But the idea is that we need one extra piece, right? We need to be able to have an answer. We have a ground truth answer, but now we need an answer that we're kind of testing. And this is where our RAG pipeline comes in. So this answer, the one that we're testing, essentially, is going to be created by our Llama 2 powered RAG system. So that's that RAG pipeline right there. And we're going to ask it the questions based on the row that we're in, and then it's going to retrieve the context. So we're going to add our contexts to this as well. And the reason we want to do that is to make sure that we have, something to compare it to. What context did we retrieve for this particular question, and are they related to the answer? Are they related to the query, and so on? Once we do that, again, we just want to put it into a format we can see. So we just put it into a data frame, and we create a data set. And then this is where all the magic is happening for Ragus, right? We call evaluate on our data set, and then we pass in the metrics that we care about. So we have our context precision, our faithfulness, our answer relevancy, and our context recall, which Greg talked to us about. Some of these require a ground truth, this specific one being context precision. Faithfulness, answer relevancy, and context recall don't actually require ground truth responses. You don't need the ground truth. So you can cut out that whole ground truth section if you don't care about context precision, which is a very helpful step if you need to do a lighter evaluation. You're not so worried about that context precision. You don't need the ground truth. And so we're going to test this by creating a Ragus data set using the helper function we created above. All that's going to do is it's going to have our LLM answer all those questions, and then it's going to pass it back to us in this data set. We're going to just save it to CSV. Again, this is in case you don't have the bandwidth to run this. You can just load the CSV files in. And then we have our evaluate, which is going to evaluate, and it gives us our score. And you can see that our score is 0.3125. That doesn't have objective meaning, right? Like this matters for this system, but it doesn't necessarily matter across systems. But it's helpful for us making decisions about, are we adding the correct things? Are we improving our system by making changes or not? So a lot of people will ask, like, what's a good, score here? What's a good Ragus score? And the answer is, you want it to be high, of course, but really what you want to see is progress. You want to see improvement over time as you change your system. We have our context precision, which is fairly low, our faithfulness, which is fairly high. These are all measured on a 0 to 1 scale. And our relevancy is quite high, which is, yeah, it feels good, man. And then our recall is, it's pretty good. So right out of the box with Llama 2, we're feeling pretty good about these things. Maybe our context precision is kind of low, but, such is the nature of the beast. And that's how you Ragus, right? It's not so difficult, fairly straightforward, very powerful, but we'll see it in action as we discuss alternate methods of retrieving with Greg, and then we'll see how we implement those alternate methods of retrieval after that.
All right, thanks, Chris. Yeah, so I just want to kind of make sure that we are as clear as we possibly can be on the Ragus framework before moving to advanced retrieval. And one of the things that's challenging all the time actually, is that things are changing in real time. I mean, they just put out their docs, I don't know, a couple weeks ago, and they're coming up with new things all the time. And they're changing the names of things, they're changing the way they describe things. We saw this with LangChain yesterday as well. And so this is part of the challenge of sort of keeping up with this. And what you're seeing too is that as they build the tooling into LangChain, as they build the tooling into Llama Index, they're choosing slightly different words. Kind of like we saw with OpenAI's user system role, and then LangChain decided to go with system human AI. We're seeing very, very similar things happening with Ragus. So this is out on the edge. And so, sometimes there is ambiguity out here, and, sometimes it's a challenge to actually dial in exactly what these things are doing and what they mean. And then definitely from a, down in the weeds vector perspective, there's definitely challenges as well. But I want to kind of just, clearly state, as best I can here, what the latest and greatest, simplest possible explanations are. And I think it's precision is measuring the relevancy Used to be called context relevancy. It's measuring how relevant to the retrieval, to the retrieved context, the question is. Okay? That's essentially the big idea here. The recall is just recall, true positive rate, of the retrieved context. So based on this answer, that's the truth, is this the context? That would give me that. And then the answer relevancy is referring to the degree to which a response directly addresses and is appropriate to a given question. Faithfulness is measuring the information consistency, whatever that means, of the generated answer against the given context. And so this is their one-liner of each of these now. And they're hard to track. But let's not lose sight of the point. The point is, can we instrument a system to give us numbers? And can we instrument a system to give us numbers where we can focus on a metric that allows us to improve our retrieval quantitatively, because that's what our bosses want to see. Okay? We can tell instantly if we ask it, what is RAG? And we do better at answering the question. Hey, that's a better answer. As a developer who actually wants to understand RAG, we can tell instantly. But this is about numerical scores. And so they've even added in the past, I don't even know, not that long, they added a few other evaluation pieces called end-to-end evaluation. And that is connecting the answer to the ground truth. So now they have answer correctness and answer semantic similarity. They used to call these aspect critiques, and now they're up-leveling this to end-to-end evaluation metrics. So it's hard to track this stuff. Again, don't get lost in the weeds, and we don't want to focus on the weeds. But there are lots of weeds to get lost in. All these words sound so good, don't they? Bosses would love this. They're so good. But are they, though? You know? Are they? We don't think so, really. The retrieval ones are pretty good because you can actually do stuff with them. And the stuff you can do is you can try to make retrieval better, and then you can see, did it work quantitatively? And that's what advanced retrieval is all about. There are a couple sort of dumb, easy things to do with advanced retrieval that you should start with. So once you get your RAG system set up, you want to then say, okay, what should I do first to try to improve my RAG system? And there are a lot of things you can do to take RAG to the next level. Lots of things. And you want to kind of break it down. We're talking about advanced retrieval here, but to put advanced retrieval in context, if you're doing big systems, cache is king, right? Cache is king. We all know that. And so why are you pumping a ton of data through embeddings a bunch of times in a row? That's dumb. Don't do that. Why are you not storing prompts and their answers that are used a lot of the same times by many, many users? Don't do that. Re-ranking is a no-brainer. So if you have 100 references, how do I take that 100, turn them into 5 of the top most useful, most relevant, most non-redundant context? And then, of course, why did you pick the chunk size that was the default chunk size? Well, because it was the default, right? Why? Why is that the default? Is that right? Should I look at hierarchical chunking strategies? Should I look at using metadata to actually take my stuff to the next level? The black art of chunking is a whole nother workshop, right? And nobody has the answer, because the answer is dependent upon your specific data. And then when we talk about hybrid retrieval, we saw some of that already, right? We saw some of that in Pinecone. It's built in. The vector databases are going crazy on this. So you can actually get a lot of this through your different component pieces. I mean, somebody's got to compete for each of these things and make it easier for people to build with these. And you best believe anybody that just got tens of millions of dollars is competing really, really hard to help take your RAG to the next level. But, it's it's rapidly evolving so quick. Like Llama Index just put this out last week, right before we did an event. And I mean, man, they are shipping like crazy. Their engineers are just nonstop putting stuff out, absolutely crushing it. And so according to Llama Index, to go from simple to advanced RAG, your sort of key things that you want to look at first, how about data parsing, chunk sizes, doing hybrid search. All of this stuff is like a level 0 thing now. And then they're putting advanced retrieval, re-ranking in advanced retrieval, and actually hard disagree because it's so easy to throw this in, and we'll show you exactly how to do this in LangChain. And it's kind of like when you do a classic machine learning model and you're like, well, what should I use? Should I use like linear regression, or how about I just pick up a random forest and an ensemble method, because that'll definitely work best. I can go through the whole thing and I can show, hey, look at all these great models I looked at, but I know ensemble methods are going to crush it. And that's kind of what re-ranking is doing. And there's just so many things that we can do. Not so many, but we showed small to big in a recent event, and we're looking at, they've released more stuff since then. This is one way to look at it, according to Llama Index. There's a lot going on, but we're going to give you 2 things that you can do in LangChain that we'd recommend. The first one is called the parent document retriever, and it's basically hierarchical retrieval. So, the idea is small documents, very, very small chunks, sizes, those are good because you can really dial in exactly what was said. And if you're going and you're trying to put that into the context window, you're trying to get as many of those specific things as possible, you're really nailing it down. But if you only take the sentence and the paragraph is actually within a chapter, and the chapter is actually within a part of the book, how much context do you actually need? And that's just a novel. Most of the documents we're dealing with are much more complicated than that. Or a technical report. How much context do I actually need? And so big docs are good too. Shoving all the context in the context window is good too sometimes, right? And how much of that should I do for my particular application? That's up to me. And so the idea is like, don't use small docs, don't use big docs, but use both. And this is the sort of parent document hierarchy. So this is, simple idea, pretty easy to implement. And so why not try it out? Try a couple different sizes. But again, the data-centric paradigm, we don't leave data-centric just because we're with LLMs and with RAG systems. This is still a place where we have to know our data better than anybody else. And if we don't, all these stupid tools in the world, they're not going to help us. All these metrics in the world, they're not going to help us. And so know your data, decide if this is relevant to you. Maybe you need more hierarchies. Maybe you need more metadata. Maybe you need to add some quantitative information with SQL databases. And maybe this doesn't make sense for you at all. The next thing that we should do that is just so easy is this sort of hybrid retrieval. We saw this. Sparse retriever, dense retriever. This was done kind of automatically in Pinecone for us, but we're using Facebook AI similarity search now. And so we can go ahead and just use LangChain to implement this reciprocal rank fusion. That's from the paper. Sounds very fancy, but this is the idea of 100 different things. Give me 5 things, because the redundant context doesn't help. And if you basically, you're teaching the kid, right, and you're saying exactly the same thing over and over and over again, it's just going to kind of repeat that thing to you. It's like, is that useful? It's like, well, not if you want to provide that information within a broader context, and you want to have it not weight that particular statement too heavily, right? So it's about not weighting things too heavily that shouldn't be weighted too heavily. And also, sparse plus dense, it does it faster too. Why shove 10,000 pieces of context into the context window and pay for all those tokens when they're not going to add anything to the actual answer that you get? That's dumb. So don't do that. And so we're going to see exactly how to do this. Now we're at sort of the meta RAG with Ragus and advanced retrieval stage with Chris.
Talk about more advanced retrieval methods. The first thing we want to do is we want to kind of think about how we want our system to improve, right? So the metric that I'm going to care about today is our context recall. I want to make sure that I'm recalling context that is more related to what we need, right? So I'm not going to worry too much about the generation piece. We can tweak that. I'm not going to worry too much about our context precision. Both of the methods we're using today are going to retrieve more information, and so it's likely that that context precision might be negatively impacted by that. We want to care about context recall, and so what we're going to do is we're going to use two methods that should improve that metric. We're going to first just create this create QA chain helper function. This is, again, super straightforward. We know the retriever is going to change, but we don't want the rest of the system to change, right? We want to kind of hold everything else in place, and so we're going to only change the retriever. The first thing we're going to do is this parent document retriever. As Greg explained, it's like very straightforward. This is as easy as it gets. The idea is that we're going to have small chunks, which we search for, and large chunks, which we use to augment our context, right? And the way that I would think about this is we are likely to find what we're looking for in smaller chunks, right? Like if we can have that kind of granularity in our chunks or in our context, we can laser focus on the right thing when we're semantically comparing our query to the to the context that we have. Now, if it's so small, though, we might lose information. And like an example of this that's, I keep repeating from a previous, learner that we had in one of our programs is, the idea of an equation in a textbook, right? When we look for an equation in a textbook, we are looking by name, right? So we're going to say like, what's Bernoulli's equation? What we look for the name of this thing. That's how we interact with it. It's text. But the name of it isn't going to be where the equation is. The equation is going to be nearby, surely, right? But it's not going to be the name. The equation isn't the name of the equation. It's near the name of the equation. So the idea is we use this small search in order to laser focus in to where we need to go, and then we blow up that context around it in order to capture the information we actually desire and to provide more context about our query. So as you can see here, we have this parent splitter and a child splitter. We have the same recursive character text splitter that we saw before. We have our chunk size for our parent splitter is large, 750 characters, and our child splitter is only 200. So the idea is we're going to scan through these chunks at that 200 chunk resolution, but we're going to retrieve the 750 chunk that the 200 chunk is part of. So the idea is, we search within those 750 chunks by this 200 size chunk, if that makes sense. And that's the whole idea here. We want to search small, but retrieve big. And that's going to give more context to our LLM, which is going to hopefully let it answer the question better and have access to better information. The way to actually set this up is we need to have this is just like LangChain specific, implementation. So this is how LangChain does this. If you're using Llama Index or you want to create it yourself, you're going to have to, use different syntax. But the idea is that we want to have this collection in our vector database, and that collection is what's going to let us associate those small chunks with those larger chunks. As well as we have this idea of an in-memory store, which is where we can store chunks of information. We don't need these chunks to have their embeddings, right? Because we're not going to search for those chunks by their embeddings. We just need the text, so we can just shove them into the in-memory store. When we create the parent document retriever, again, LangChain specific syntax, we're going to add our vector store, which we've just created. We're going to add our doc store, and then we're going to add our child and parent splitter. To be very clear, the vector store is going to hold our children, so that's going to hold our small documents, and then the doc store is going to hold our large documents. Again, we don't need to search for those large documents. We only need to search for the small documents, so we don't need a vector store for our large documents in this case. And we just go ahead and add a bunch of documents to it, right? We're going to add our documents as they're created by the parent, and then we're going to split them into smaller pieces, and those are going to become our child documents. And there you go. We're going to go ahead and give it a test. We're going to go ahead and give it a, create an evaluation data set, and then we're going to go ahead and evaluate it. And we can see that our overall score suffered a bit, right? Our context precision was hit pretty hard, which makes sense, right? We're adding a bunch of extra information, so it's less of our context is relevant to the query. Our faithfulness, about the same. Answer relevancy takes a hit, but our context recall went up, right? We're more likely to receive the correct context using this method than we were using the other method. So that's, well, we're going to take questions at the end, sorry. Yep, no worries. You almost got me. We have ensemble retrieval next. This is a very classic approach if you're used to search, like, this is going to be something that you're familiar with. The idea is that we've been talking this whole time about dense vector search. It's very good, right? Like, it does what it says on the tin. It lets us find that semantic similarity, but it's not the only way to search text. In fact, there are a lot of very powerful, very good sparse search methods, right? So things like keyword search or just finding the information we need by matching a pattern. So the idea with the ensemble retriever is we're going to combine those two results. We're going to find some documents through a sparse search. We're going to find some documents through a dense search, and then we're going to combine them together using that reciprocal rank fusion that Greg talked to us about, which is going to order them based on the order that they were retrieved in from each disparate ranking system, right? We have two different ranking systems, and reciprocal rank fusion is going to help us combine those two together. It's very straightforward to do. In LangChain, we're going to set up a sparse retriever. We're using BM25. You can read more about that. This is kind of like early Elasticsearch stuff, if I recall correctly. If not, please let me know. But it's a good sparse search method. It's lightweight, does its job. We're happy about it. We have our vector store here, which is actually going to be our dense vector search. Hopefully at this point we're used to that. The idea is same as before, right? We're going to embed a bunch of documents, get their vector representations, and use that to search our corpus. And then we have our ensemble retriever, which is going to just retrieve from one and the other, and then combine them with this specific weighting. So one of the things that I want to highlight to you is that this weighting can have a significant impact on the performance of your system, right? If we're in a situation where perhaps we know that we want to augment our results with that sparse search, but dense is really where we're going, we care deeply about that semantic representation, then we'll want to weight towards that. And then the opposite is true if we're in a situation where we care a lot more about that sparse search. But the idea is you can weight them as you see fit, and this is a hyperparameter in our RAG system that you can fiddle with to adjust the score. We do the same thing as before. We're going to go ahead and create our chain. We're going to test that our chain works. We're going to evaluate or create an evaluation data set using that chain, and then we are going to evaluate that data set using Ragus. And we see again, the Ragus score, it's maybe not so good. Context precision, again, we know we're retrieving more information. Makes sense our context precision is going down. We're not really doing anything to ensure that we're only retrieving super relevant information. We're just retrieving more information. And then we have our faithfulness, kind of the same-ish, and answer relevancy, kind of the same as the last method. But our context recall now is significantly higher than where we started. And that's what we're going for, right? We want to get that higher context relevancy. And one of the things you might be thinking as well, if we're just retrieving more documents, and of course we have higher context relevancy, but in this case we're actually retrieving less documents than we would have retrieved using the basic retriever. So the idea is that this is still an improvement despite we're actually retrieving fewer documents. They're just more relevant documents, which is what that ensemble method helps us to do. And that's basically it. That's the idea. We are going to take our select a metric with Ragus. We want to optimize that metric, get it to a place we're happy with, and then start focusing on the other metrics, right? We want to look at perhaps methods that we can use to improve the precision of the context, right? We want to look at methods that might impact generation. So how do we make our generator work better here? Playing with the prompt, playing with what generator we're using, right? Playing with the actual embedding model we're using. There's lots of different strategies. These are just two, and these are two that do well to improve our context recall. But that does not mean they're the only two, nor does it mean they're the best two for your use case. We like to meme about it or whatever, but the R in RAG is the thing that needs the most work. It is the thing that takes the most engineering hours. If you are going to spend 10 hours working on one part of the system, 10 hours spent on retrieval is going to do a lot better in most cases than 10 hours on anything else. And that's the idea of these advanced retrieval methods. They're simple to implement, and they do make for a more performant system. So there you go. We'll pass back to Greg.
All right, thanks, Chris.
I'm going to keep it light, keep it tight here, and get Chris back up here pretty quickly. So the idea is we've gone through LangChain, what's happening at the edge here. There's actually some retrieval metrics, some stuff built in to this new platform. We encourage everybody to check it out. Beta sign up is there. Chris will show you what it looks like behind the curtain here, and we want to make sure we have plenty of time for questions. There's probably a lot of questions about, well, what about those numbers? And we are excited to talk about those with you. But for now, what we want to do is we want to kind of show you a little bit about, at even the highest level, it's not just about evaluation. It's much more than that. It's also about when stuff breaks, how can you kind of figure out what's going on? How can you actually look inside and be like, can I see inside the beast, inside the machine? Can I see it? Is it visible to me? And visibility is sort of the precursor to observability, right? And when we talk about MLOps observability, there's probably a bunch of platforms here, and you guys are familiar with kind of how all that works. And the big idea is that visibility is just seeing it. Observability is sort of instrumenting it so automatically it will detect it, and it will tell you, hey, fix this. So right now we're having humans build these things, and then it's like going wrong and it's breaking, and then it's like, where did it break? And it's like, can I even see it? And that's the visibility tooling. WandB came out with Trace, and they were sort of a leading LLM ops tool. They were putting the A16Z article, one of the first people that used LLM ops in their marketing materials, and so you'll find them. They're very well indexed with SEO because of that. And they have trace table, trace timeline, and it's all about, can I see the inputs and outputs of anything in my chains, right? Can I see the entire execution flow? And can I see all the details, especially if I get an error? Can I see all the details of where that error is? Now, as the industry goes, from WandB to LangSmith we go, it's no different. This is a LangSmith image. This is WandB copy, okay? So it's that straightforward. You can visualize and inspect the execution flow. You can analyze the inputs, outputs, and intermediate results of your LLM, input, output, right? Execution flow. Look at that, the trace, right? So we're seeing this sort of adoption, this stealing like an artist from one platform to another, which is the way she goes. And then we're securely storing and managing prompts. So this idea of prompt caching, this idea of making sure that you're tracking what your users are actually putting into your application, very, very important. right? Just like any AI application. What are you actually collecting from your user when they use it? So all this stuff is very important beyond just evaluation. And interestingly, too, and we were talking to a couple folks way out on the edge, where it's like, how can you use LLMs to do evaluation for you against other LLMs? Not just in the provide the answer, but in the come up with a way to evaluate, a custom way to evaluate through natural language. So we're going to show you a toy example that we think is pretty lit, actually, and we're going to ask, on a scale of 0 to 100, how lit is the following response? And you can be as silly, as mild to wild with this prompt engineering and evaluation using natural language as you want. This is built into LangChain. So we're going to have a model assess how lit our answers really are. And that's sort of, in a nutshell, the state of the art of evaluation. You can do stuff like this, and you can probably show your boss that numbers go up, and you can make everybody happy. And so it's not about the numbers. It's about, is the thing actually going to be better for the user? Is the thing actually going to be better for your use case and application? So with that, let's get Chris back up here to show you production LLM stuff, and then we'll go ahead and close out. Start with Q&A.
It's me, Chris, again. So we're going to talk about LangSmith. LangSmith is LangChain's solution to the visibility problem. I imagine eventually more towards the observability problem. But for now, it's pretty good at what it does. You can use you can follow along in the notebook if you use tinyurl.com/LangSmith, all caps. But you will need a LangSmith beta account in order to use it. So this is more of a demonstration than it is something you're going to be worked through right now. But if you haven't signed up for the LangSmith beta, please do so. It's an incredible tool. So first of all, how do we actually, use it? Well, it's pretty difficult, so we're going to walk through it top to bottom. Number one, the example we have does use OpenAI, so you'll need OpenAI. You'll need to provide the key. So you set this stuff right here, this cell, and then you're using LangSmith. That's what it takes, right? So similar to weights and biases, similar to other tools, it's very straightforward to get going with these tools. LangSmith and LangChain obviously are very tightly integrated. The idea is that this is going to work out of the box with LangChain with no real effort on your end, and it's going to give you a lot of insight into what's happening inside your systems. So the idea is we have this tracing, we're going to set to 2, we're going to create a project. This is associated with this instance. We're going to point it at the endpoint, and then we're going to provide a API key given to us by LangSmith. We can start this client, though we don't need to. This is just to use something we're going to leverage later on. And then let's create that same RAG system that we saw before, but this time even simpler. We're going to go ahead and we're going to create a way to interface with our archive documents that's even more straightforward. So we're going to give the archive tool to our LLM, and we're going to set up this small agent chain, which is just the archive tool in our LLM. All this is going to do is when we ask a query, it's going to fetch relevant information from archive and then answer the question based on the fetched information. So super straightforward stuff. We can ask it things like, what is QLoRa, right? So this is a quantization training method, and it's going to tell us, going to give us a bunch of information, and it's going to say QLoRa is an efficient fine-tuning approach for large language models, and it goes on and on. So this is the idea of this tool, right? We can ask it questions, it will fetch relevant information from archive, then answer those questions. RAG. Let's just, take a bunch of questions and ask our tool about them. So we'll just run through a bunch of random questions, and we will see what the model says, or what the system says about them, and that's it. That's all we're doing. The reason we want to do this, of course, is to showcase all of those calls in our, I'll zoom in here for sure, is to showcase all of the information that we gather through that process from LangSmith. So you can see that we get this overview of our project. We get how many runs are in our project. We get the total number of tokens used in our project. We get these P50, P99 metrics on, how quickly, what's our latency looking like, in the worst case and in kind of the average case. A bunch of really quality information. As you can see, we could spend, an hour, 2, 3 on just the interface here, but we're gonna zoom to some of the highlights. So we can filter everything. We can see individual request latencies. We can look into each of these chains and see what's happening. So let's look at this trace together. And this is basically our full trace for our prompt from input all the way to the response. So we have, number one, it tells us the success. We have the chain. We have what happened in this chain, right? We have the tool that it accessed and how that tool interacts with our information. And then we have our chain that, based on that context, is going to give us an output. So we can go as deep as we want into the trace. This is going to tell us how information flows through our RAG system and give it to us in a kind of, very easy to see visual way. We can see the stats of each of these components, right? So how many tokens were used at each step. We can see, all the way down to the actual LLM calls. So this is when it's going to hit the LLM and back. LangSmith gives us everything that we need in order to observe, where are the slowdowns in our system. We can see here the LLM chain at 3 seconds, the tool access, very, very little time makes sense. It's not really reaching out to anything, right? And then our LLM chain here at the end is taking up a brunt of the time, so we can diagnose and improve our systems by using this information. So it's absolutely an amazing tool. Beyond that, though, once we've answered all these questions, right? So we have now this set of 7 things that we're tracking, right? 7 runs. We can. This is wait for all tracers is basically just saying wait for whatever's currently running to finish running, and then continue. This is not necessary, but for the purpose of the notebook, it's just good to run it to make sure you're not, getting ahead of yourself. We can create what's called a data set with LangSmith, and a data set is going to be a collection of our inputs and responses. Data sets can take many different forms depending on what you want to track. We're going to be using this kind of key value data set, which is going to associate inputs and outputs so we can evaluate them using LangSmith as well, because of course we can evaluate using LangSmith. What we're going to do in order to do that is create an agent factory or a chain factory, whatever you need. The idea here is, again, we want to create a consistent tool. So we're going to have this agent factory produce our tool, right? Whatever we're testing, whatever we want to evaluate. So we're evaluating this simple agent system. You could be evaluating your whatever, complex application. It doesn't matter. We have to have some kind of factory that gives us that object so we can evaluate it. We have a number of different evaluation methods in LangSmith. We're not going to go too deep into them right now, but they're worth looking into. But the idea is that we have things like QA. How correct is your response based on the reference answer? What's the embedding distance between 2 responses, right? So our desired response versus our response. How similar are they, right? Labeled criteria. We can just put stuff in here and, it can evaluate it, smart enough. And then, of course, custom criteria where you can build whatever interesting metrics you want. We've used, obviously, like a silly one just to showcase it, but you can use whatever you'd like, and they can be pretty intense as well. We're going to showcase building the silly example, and then, the idea is you can extend that to be whatever you'd like. But we have this dopeness evaluator, so this is going to measure how dope our response is on a scale of 0 to 100. How this should say dope is the following response. We're going to use GPT-4 to do this. You can see that this is just a prompt, right? We're going to pass this to our LLM, and it's going to give us a 0 to 100 score of dopeness. And then we have the rest of our kind of properties we have to set up so that it can interact with LangSmith properly. And then we have our evaluation, which is just going to convert our response from the LLM into a format that we can use numerically, right? So it's going to convert our 0 to 100 string response into a number, so we can mark it from 0 to 1 like every other metric. So you can see here, LangSmith has a run, evaluate, or eval feedback object, which we can pass evaluators into. So we're going to pass in our QA. This is how correct the answer is based on GPT-4's understanding. We have our embedding distance evaluator. We have relevance. So this is just a labeled criteria that exists within LangSmith. How relevant is our answer to the context, right? This is something that we can use to track our retrieval pipeline. If the answers that or the context we get is relevant, we're feeling good. And then we have a custom criteria called fully answered, and simple enough, right? Does this response fully answer the question? Is this something that we see as being a complete answer or not? And then, of course, we have our dopeness evaluator. In order to run this evaluation, right, so that was a lot of setup for sure, but in order to run it, this is all we need. We can do this a run on data set. We pass in our client. We pass in our data set name. That's the data set we created earlier, which was just based off of prompts. If we were in a production setting, we would just create a data set based off of a subset of our users' interactions with our system. And then we need to pass in our agent factory, our evaluation config, and then we can tag this as well so we can see it easily in our LangSmith tool. So we have the thing set up here, right? So this is run on that data set that we were talking about earlier, so 7 runs. You'll see that it took a lot of tokens to get this done, right? 32,000 tokens in order to do this evaluation. So please don't be tricked into thinking this will be cheap. This is a process that's going to cost you if you're using OpenAI. You can see our latencies again, and then we can see like the kind of meta evaluation here. We're pretty relevant, not so bad, absolutely correct, which feels pretty good. High dopeness, it could be higher though, so obviously we have some work to do with our prompt. Most questions were fully answered, at least all the ones that we managed to successfully evaluate. Our embedding distance, however, is quite low, and so that's something that we want to look into and address and improve. You can see here that most of our runs succeeded, but not all of them did. We have a warning here, and LangSmith can tell us exactly what happened. And as you can see, it looks like our request actually blew over the context window limit, and so this is letting us know what the issue is, and we can use this information to solve that issue. And you'll notice that none of our, nothing that we ran in the notebook failed or indicated that this was the case. So it would have been silent if we weren't using the visibility tool, but we were. So it's, we get this information. And that is LangSmith in a nutshell. Amazing tool. Sign up for the beta and start using it.
Right, yeah, so let's go ahead and close this thing out. So in conclusion, eval is very much evolving. Ragus is absolutely leading the way, and we see that eval, whether you do it with humans, whether you do it with machines, it's not super cheap, in general. And so, make sure that it's worthwhile and you're evaluating useful things, for sure. We're seeing LangChain, aka LangSmith, build in tooling to actually evaluate. We're also seeing Llama Index do the same thing. And yeah, definitely sign up. We're kind of predicting this is going to be a little bit of a game changer and going to really set the tone for the next phase. And so, definitely get your hands on this if you want to be out on that edge. All right, so don't forget to build, ship, and share. For 10 years I saw the only people that were succeeding in a 21st century workforce were the people that were learning new skills, using those new skills to build things, and sharing those new things that they built with others over and over and over and over. All of us know very well how this game is played because you're here in this room. It's not about degrees. Certificate, schmertificate. Don't worry about those stupid pieces of paper. Build cool shit with awesome people. Join a community of makers, maybe AI Makerspace, and build, ship, and share together with us. We'd love to have you. If you liked our content, we'd love for you to like and subscribe. please like and subscribe. We got a Transformer event coming up. We got a ton of events coming up for the rest of the year, and this is our thing. And we're actually a lot smoother online than we are in person. We're working on the in-person game. So please check this out at AI Makerspace on YouTube. And last but not least, if you're sick and tired of the way people talk about this stuff, we're here to help. We've got an event on this next week. So please check it out next Thursday, I believe. November 1st. We're going to be talking about how to not do this to people ever again, or this, okay? And then additionally, finally, if you really liked the content that we showed today, our flagship course is not the one that we're going to be talking about with Transformers. Our flagship course is LLM Ops. And so this is going to take us through everything that we saw in these last 2 days in a much more detailed way. We're going to see LLM Ops visibility with weights and biases. We're going to see RAG, OpenAI, closed source, open source. We're going to see all the stuff you saw, a lot more detail. We're going to do it. We're going to show how to deploy stuff, build front ends, put it on Amazon SageMaker, do deployment, production endpoints, and then of course agents. What's the state of the art with agents? What's the state of the art with advanced retrieval? All of that is in this course. This is the one that's going to start just after Thanksgiving. So let us know if you have questions about this. Come to our booth at the Startup Corner. That's it, everybody. Thank you so much. We are going to open it up for questions for the last 15 minutes. We appreciate your attention today, and like and subscribe our personal channels as well. Thank you so much, everyone. And the wizard.
Yeah.
So we are gonna, if you'd like to leave, go ahead. You are relieved, and you can do that. Sarah is gonna walk around, I believe, with a microphone. Is that right?
No, but I'm loud enough for everybody to hear. If your guys are all down, can we do a selfie?
Oh, absolutely. Yes. All right, everybody. Yes. All right, everybody say, rag, spam it, yeah, nailed it. Good call, okay. I'm just gonna repeat questions after people say them so that we can make sure that the recording is all set. Is there an invite code for LangSmith? Sarah, do you want to run around with the mic?
We don't have the invite code. You have to sign up through the beta. I don't have any codes to give out or anything today, unfortunately, no. Yeah.
All right, other questions?
So yeah, question on this weights that you have mentioned, 0.5 and 0.5 for the observed and then the best weights. So is there any research that is coming on in like a hyperparameter tuning for those weights as well? I mean,
research maybe not. I mean, yeah, you can build that system, I think, fairly straightforwardly, the same way that we would do kind of that search. You know, like if you're used to hyperparameter tuning from traditional machine learning, you can do like the same grid search kind of thing, or the Bayes search. So it's up to you what you do, but there's no specific research on like what weighting is going to be optimal or how to achieve the most optimal rating, because the rating is very dependent on what your actual documents are, what your actual information is. You know, the amount that you need to weight the semantic versus the sparse is it comes down too much to your actual source documents.
Yeah, I have one more last question.
Yep.
Now we are building RAG, right? So, and again, we are doing like a feedback loop mechanism where we are using RAGas and then getting the score and then again returning back. The time it's taking for the prompt to get as a response, it's again increasing a lot. So how is the next, like what are the next steps that's reducing this time? Like, is there any research going on in that space as well?
Yeah, absolutely. I mean, every single part of the RAG pipeline has latency. Even the transition between elements in the pipeline has latency. So anything you can do to use a more efficient embedding tool, right? And Hugging Face is coming out with optimizations if you're using those, open source alternatives, batching your embeddings. There's all kinds of tricks you can use. Cache is king. I know we've already said it, but being able to cache everything that you can in order to reduce that latency. And then, of course, as we talk about the tools like your actual LLM, making sure that that's deployed in a way that is giving us efficient and fast inference is another thing that's going to add, especially if we're hitting the LLM multiple times, right? We're going to multiply those time savings, but ultimately, every single part of the pipeline can be and should be optimized as much as humanly possible. The thing we want to avoid saying, though, is when you're starting, when you are a business that's on day one, we're not talking about optimization, we're talking about working. And so, that's something you want to focus on as you mature in your use case.
Thank you so much. And you guys nailed it. Thank you.
You nailed it, Ravi.
My question is, what are the best practices for chunk sizing in the vector databases?
Yeah, such a great question. If anyone in the room has an objective answer, please let us know. All I can say is that 42. There you go. It's going to depend so much on your documentation. It's going to depend so much on the kind of information that you care about. Things like, say Wikipedia pages or PDF documents or reports that have a consistent structure. There's kind of an answer, right? Which is that we want to retain those units as much as possible. We want per paragraph chunks, right? We don't want to have 4 chunks in a paragraph, or if we do, we want to use that hierarchical retrieval to blow up to the full paragraph. But there's not an answer to this question that's satisfying because it's entirely dependent on your use case. It's entirely depending on what source documentation you have. I would say the best place to start, though, is really study your documents, really study your source information, and we want to keep as much information together as humanly possible while dealing with our context window. And another thing that's maybe not as trendy to say, but this is what data science is really good at, and this is what data scientists are very good at, is helping inform us and guide our decisions. And so, the role of that data science person is not going away. They're very instrumental in determining how much information consistency do we have within our chunks, and how do we optimize that information consistency in the chunk. So I would say your data science team is going to be your best asset for determining that.
Yeah, but first you have to teach them about RAG and about how all these things work in the first place. And this is why most of them are going to be outdated. So make sure you push them to this sort of content. And I would also say, if you're interested in being the ninja of the black art of chunking, reach out to us and you can hold we'll put you on a platform, hold a monthly series on chunking. Somebody needs to emerge as the chunk master. And we're going to see, I believe we're going to see, Chunker, Chunker without the E, sort of platform tools, things come out like that, people building these things in. Whoever builds that, whoever becomes the expert at that, I would expect an acquisition before too long. So, all right, next, what do we got?
Yeah, in terms of the data set generation via GPT-4 that you guys were doing, did you experiment with generating questions and answers across different documents, or are there strategies to make this more complicated and therefore also more realistic?
Absolutely, yeah. So you can chunk the contexts different. So you can use very naive chunking in order to generate those data sets. You can do things like ask it to generate a tricky question. I mean, there's lots of levers that we can fiddle with in terms of generating a more complex data set that might not be as specifically answerable by the system. I would say the easiest way to trick it is to ask it a question that you would need to make an inference past the context, and then we want to see our RAG refuse to do that, right? So there are a number of ways we can create a data set that is quote unquote tricky to get more realistic performance. Absolutely, yeah. Yep.
Yeah, quick question about the vector store. So I know the traditional vector store, you can retrieve top K for your context, but recently I ran into a case where I need to pretty much do a select all from all the documents that I've embedded in my vector store and then use that to organize my RAG system. Do you guys have a recommendation on what's the best way to do that? Or should I just use a traditional database and run like SQL query and get everything?
Yeah, I mean, there's kind of like higher level ways that we can filter down the data that we have. So metadata filtering is something that we can use in order to pare down the amount of documentation that we have that we're trying to retrieve. In the case that you have to look over everything, I think the best tools are things like NL to SQL systems that can help us take that natural language query and create a SQL query that retrieves the correct information. The systems right now, if you use these larger models or if you fine tune a model on the natural language to SQL translation task, are fairly robust. So I would say that's probably your best bet if you do need to look through all of the information every time.
But so you wouldn't recommend a vector store to run like the select all statement because that's not really fitted for the like select all statement, right? Like, would you recommend a different traditional database?
Yeah, you can put these systems on top of traditional databases, absolutely. So you can actually have the natural language act as an interface between you and the database, or say a subcomponent of your RAG system and the database. So you don't have to have it select all. You can have it dynamically determine which query is best in that case, which could be select all, of course. But those systems are going to help us leverage that resource, a traditional database, in a way that interfaces very nicely with RAG and in these orchestration frameworks.
Thank you.
Yeah.
I can shout as well. I'm curious on the kind of limiting costs in a sense from the maybe latency perspective. Like you can obviously do all the requests for the network that it's caused by itself. So what would it take, or how much would each component be in size to put everything on one machine? That's what I'm trying to get at.
Oh, sure.
Everything locally run it.
Yeah, so the question is, do we want to just kind of have everything running on the same machine? And the answer is probably not. I think that there are definitely parts of this system that should be separate to each other, that can be run on different levels of hardware, where we need, say, a lot of compute for our LLMs. We don't need anything for most of the rest of the process. That is going to introduce latency, but it's going to massively save on cost, right? We don't want to have necessarily our whole system running on something that is going to cost us a lot with like a GPU instance, right? Or something that needs to have our GPU cluster spun up all the time. We might prefer to have that RAG component on a different machine that can leverage caching so that if it doesn't need to hit the LLM, we don't have to touch the GPU, and that could significantly impact cost. So the intuition is definitely want to separate out the LLM components and then the rest of the application logic. Whether or not that all fits on the same machine is going to depend a lot on what you use. There are a lot of really cool like Redis-based vector stores or caches that you might want to implement that could definitely part of a different machine or certainly a different container. So, but great question, yeah.
Yeah, Olympia, close us out. Last question.
Oh, thank you, thank you. Yeah, so the question, kind of different question, is whether the retrieved documents or the answers per se of the LLM, do they go as a feedback to improve the model, or they're just kind of lost in space?
Lost in space, lost to the ether. Tools like Langsmith and weights and biases and other Arise tools that are meant for visibility that help us cache those things, let us leverage that information that is otherwise lost, but without those systems in place, we just lose it and it's gone.
Yeah, and I do think like we are seeing like one of the recent events we did, we called it Smart RAG, and it's basically trying to fine tune the embedding model and the LLM model within a RAG system. While these things are lost today, I think the way to sort of start thinking about how we can potentially use them is you basically generate the same triples or quadruples to do this sort of training this fine tuning of the embedding and the LLM model. And, you know, I think somebody's got to sort of close the loop on all of that. And, you know, lots of cool stuff to be built, lots of great work to be done. Hopefully many of you are going to be straight crushing it and being the ones out there. And we will close on this legend's question. I suppose it's going to be really good. I was speaking to this guy yesterday. He's a straight G in the game. Down on the end, Sarah. And we'll close it out strong with this one.
Thank you. So question is, most of these things with RAGs, they work on free-flowing text, right? What do you do if you have, say you have a PDF and you have tables in there, which is a two-dimensional data, right? How do you extract information from them? How do you chunk in that sense? How would you work around those information? Because a lot of PDFs and everything have tables in them, and I want to be able to query those. How do I do that?
Yeah, such a good question. Everybody's focused on this. Technical manuals are much harder than law documents. And this is the number one question we get from corporate clients is like, I have tables, I have charts, I have pictures. I want to do all of it magically, auto-magically. And the answer is like, well, you know, there's no great way to do it all auto-magically right now. You have to sort of engineer each retrieval piece yourself, and if it's not just read the PDF, then it starts to get more complicated. And it kind of goes back to classic data engineering in some sense, where you have to kind of build the pipeline to extract the stuff from the tables in the exact way that you want. And everybody's like, is there a magic OCR button that I can press? And the answer is like, no, there's not. But talk a little bit more about how you might actually engineer that solution. I'm going to pass it over to Chris to close us out strong here.
So there's an auto-magical solution now, and it's implemented in both LangChain and Llama Index. I'm tongue-in-cheek a little bit, but there are systems in both of these frameworks now that are much better at that task than we were, you know, even just a few months ago. And some of them are actually like good enough. So are you going to get to that, like, you know, super consistent level? Not today, not without an engineering team and multiple different pipelines where you're really going, your data engineers really have to work hard to figure out which section's going where. But LangChain and Llama Index both have good enough solutions out of the box that you can implement in a few lines of code. And this is why this space is evolving so rapidly. And it's like, you know, when we look back on this video next week, right, we'll be able to say, oh, actually, here's the tool that does that for us. But both libraries right now do contain tools to do it.
Yeah, and event coming up, Llama Index on exactly how to do that thing. We saw that they came out with it, so we're scheduling the event. We don't have a date yet, but like and sub on YouTube, and you'll see it soon. Thanks, everybody, so much.